Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Martin Whitlock, CTO of Telenor IoT. Telenor IoT is a world-leading provider of managed IoT connectivity and cloud services for cost-effectively building and operating both large-scale and smaller IoT solutions. In this talk, we discussed the impact of 2G and 3G sunsetting on IoT device manufacturers, owners, and operators. And we also explored how companies can minimize the impact of 2G and 3G phase out on their customers and how they can future-proof devices that are currently in design and production. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT research, strategy, or training initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you. Martin, thanks for joining us on the podcast today.
Thank you, Eric.
So let's see, where are you sitting today, Martin?
Today I'm sitting in Stockholm, where we at Telenor IoT have our head offices. So actually broadcasting this from my home, still living in the hybrid environment after COVID, I guess.
Yeah, okay, beautiful. Yeah, I spent some time in Stockholm back in the early 2010s with my previous company. It's a beautiful city, and I'm sitting in Shanghai, so I'm very envious of your COVID policy because we're dealing with zero COVID. So you can imagine that's a different situation entirely.
I can imagine that, yes.
And you are CTO of Telenor IoT. So I'm familiar with Telenor and I'm familiar with IoT, but maybe you can start by giving us a good brief of what does Telenor IoT encompass?
Absolutely, I'm happy to. Well, Telenor being one of the main telco groups in the global sense, we have, of course, operations in many markets, primarily in the Nordics and in Asia. Then Telenor IoT is the entity basically doing the IoT business, which could be both local in a business unit or as the organization that I'm actually representing, Telenor Connection. We are focusing on international IoT business. So that means that it could be for customers anywhere in the world and for devices that are deployed in both our home networks, of course, but more often in other operators' networks using roaming or other types of collaboration. So solving the international IoT business of enterprises that typically go global with their connected devices.
Yeah, great. And today we're going to be deep diving into this topic of sunsetting 2G and 3G. But before we get into that, it'd be great to get a little bit more background in terms of the scope of your business, because that will probably define also the scope of our conversation. So are you covering B2C devices, enterprise and industrial devices? Are there particular asset categories or industries that Telenor IoT focuses on?
Well, we as a company, we primarily do business to business, but that doesn't rule out that our SIM cards are finally entering consumer type of devices, because our customers might be in a B2C business to themselves. So I dare to say that there's probably not any vertical or use case for IoT that is not somehow covered by our customer base. We serve utility companies, automotive, fleet management, industrial manufacturing, whatever. It's a wide range of customer base, and they are situated, as I mentioned, also internationally. So they could have their headquarters basically anywhere in the world. But then legacy-wise, obviously being a Nordic company, we have been quite strong in the Nordic region and had the opportunity to support some of the forward-leaning companies taking their connected trucks and cars globally at an early stage. And I think that is a journey that we've been happy to be part of and now have made international and continue to build on.
Yeah, great. And maybe we can do a quick 101 on
what it means for a telecom when you move from serving, let's say, cellular devices, which I guess was, or internet connectivity, which is more the traditional business where people tend to stay put with their devices in one country, and then move to IoT devices where they can kind of end up anywhere in the world, be crossing borders, et cetera. I think that'll also be a topic that's relevant. But what has that meant for Telenor as you move from servicing a geographic region to servicing devices that could be anywhere in the world?
Yeah, I think for Telenor IoT, this is sort of the prime spot of what we do. I think we realized rather quickly by actually helping these companies that wanted to go international from the Nordics that it requires a certain amount of processes and operational excellence to make this convenient. Because, yeah, even if we're talking about standards and we're talking about networks that should behave in a similar manner, regardless of where you are in the world, we know that there are some odd cases and some challenges to making that seamless, totally seamless. And I think that's where, at least we come in for our customers to be providing one interface basically for a global connectivity and making sure that wherever this device actually pops up in the world, once it's sold and in the hands of the end customer, we make sure that it's run and operated in a similar manner, regardless for our customers, so that they can use us as a single pane of glass or one-stop shop, whatever you want to call it, to make that happen. So that's it shouldn't be underestimated, the complexity of it, but I think it can definitely be done. And I think it become more and more important actually for many manufacturing enterprises today to be able to benefit from the IoT use cases, regardless of where in the world they are selling the devices.
Okay, great. Yeah, I think this is a topic we'll return to later. Certainly, when we're talking about sunsetting networks, then if you have a fleet of devices that are deployed in Ghana and Sweden and Brazil and Japan, you're going to have different situations evolving around the world for your fleet. But let's take it step by step. So as we begin discussing the concept of telecoms now sunsetting their 2G and 3G networks, maybe we can start very basic. What does it mean to sunset a communications technology, and what exactly are we sunsetting? Are we seizing updates of the networks? Are we stopping maintenance? Are we doing a hard cutoff where we basically turn the equipment off? What are we exactly talking about here?
Yeah, I think the short answer is that when you sunset network technology, it's basically being shut off. I think it's hard to stop doing patches and upgrades as long as you operate the network, because we all know that the things like the security environment around the world right now, I mean, you need to stay up to date with the latest patches and things like that. So as long as you have a service, I trust that operators, wherever they are, have a good quality of it. But then at some point, legacy technologies become obsolete or actually not efficient enough to cope with the expectations of today's communications. So I think that's when operators start to plan for a controlled sunset. And I say controlled sunset because I don't think that anyone is just deciding from day to day that let's shut this network off now. Usually these are things that have been planned for a few years ahead, and then communicated, of course, to the market and customers in the best way possible, and then eventually someone pulls the plug. But the need for it at some point comes, I think, and it's not anything new as such. I think looking beyond the cellular technologies, we have all seen the sunset of the telegraph. We have seen sunsets of DSL lines in many markets in favor of fiber connectivity and such things. So I think it happens all the time, and it's probably part of the natural evolution. But now it starts to become the turn of 2G and 3G when looking at the cellular technologies.
What's the business logic behind this? Is it because I imagine that when you sunset 3G, for example, there's still some set of devices that will be then to some extent bricked because they didn't plan, whenever they were deployed 10 years ago for different generations. And so there'll be some maybe small set of device operators who will be unhappy about this. But is it basically the business case of saying, okay, now the pool of devices that require this is sufficiently small, and it's an inefficient system to maintain, and therefore we just are going to decide as an industry to move forward? Or how are these decisions made from kind of managing the needs of the different stakeholders involved?
Yeah, I think that usually there are a number of different parameters that needs to be weighted together. And you're right, there will be situations for some that suddenly won't have a service that they've had in the past because of this. So that's the drawback of it. But as you mentioned as well, there is a natural evolution, and that comes also into the devices and the hardware that are out in the field, that they are also being modernized and replaced. And at some point, it doesn't really make sense any longer to maintain the legacy networks. And I think the primary drivers for it is, of course, that technology has caught up with some of these technologies that we have been running for a long time, decades even. So 2G and 3G, they have both served us well. Made a lot of impact, of course, and contributed to where we are today. But looking at the performance from a data rate perspective, from a spectrum efficiency perspective, power consumption, which is, of course, something that is a hot topic these days, at least here in Europe, where we have the energy crisis going on. I think there are a lot of reasons for starting to shut off these legacy networks and instead deploy more modern technologies that will serve the market and the customers in a great way in the coming decades. So these are the things that needs to be considered. But I think it's not one parameter that has been looked at. Then some parameters might be important. I think even talking again about the power consumption, looking at the technology like 3G, which is actually rather, consumes quite a lot of power. I think a lot of operators these days need to take into consideration that they have a fairly empty 3G network, most likely, because most devices have already moved into 4G or even 5G, but it's being consuming more or less the same type of power that it has since its heyday. So I think that is definitely something to look at also from a society perspective, how we can support each other to preserve electricity capacity.
Oh, that's interesting. Okay, so the electricity consumption doesn't necessarily scale with the devices; it more scales with the network, and you then have to have economies of scale then to use the network efficiently.
Correct. I think often it's about shutting off hardware at the end, which is currently being dedicated sometimes to a certain network technology.
Well, let's then discuss where we are today. So we can look at 2G and 3G, and maybe it makes sense here to look at this geographically, because I suppose Sweden, for example, has probably moved away from 2G quite a while ago, and maybe sub-Saharan Africa is still relying on 2G for more use cases. But where are we around the world in 2G and 3G networks today?
Yeah, actually, you're not quite right with having moved away from 2G even here in Sweden. We have communicated an end date for the 2G networks, which will be sometime 2025, but we're still operating those. And that is actually the case in most markets around the world, that the technology is still around. There are a few markets that have either already shut off the last networks, like I think in Malaysia, they're quite far ahead on that. In US, there's communication that during next year, the last 2G network will be shut off and so on. So there are some markets where we see a total sunset already, or at least in the near future. But on most markets, it's still being in the planning and communication of setting end dates phase. And it does look a little bit different depending on where you are in the world, as you're hinting as well. I think in the EU and Europe, you have mostly seen 3G sunsets so far than 2G actually. And there are probably a few reasons for that. One being that 2G might be the network technology that has been providing coverage for the longest time and is provides the best coverage, and also operates in slightly lower frequencies, often the 800, 900 megahertz band, and that means that you have better radio propagation and thereby provide a coverage profile that spans across geographies in a better way. So for that reason, you sometimes want to keep it alive just for that. But then we have other things, and actually the IoT business as such is one driver for maintaining the 2G networks in some cases, because because of the legacy, because of the fact that we have, which is fantastic in itself, we have IoT applications that have been around for 15, maybe even more years and still operates actually, which is kind of fascinating in itself. And even if handsets as such are not using 2G in a large extent, there are still connected M2M and IoT devices that use it. We also have a situation in Europe where you have fairly recent regulation enforced in e-call, emergency call for vehicles. So all newly sold vehicles since 2018 need to have this e-call service in place, which is standardized around 2G still. And I know that the industry is working hard on moving forward into more modern networks there. But yeah, we have certain elements that actually keeps the 2G networks alive in Europe. But 3G, on the other hand, has started to be reformed so that we can use the spectrum for 2G, for 4G and 5G technologies instead. Then looking at Asia, it's often is a little bit different. Then 2G has been sometimes sunsetted first. Maybe there's not too much of dependency to legacy networks, legacy installed base, but rather the fact that 2G is even less efficient than 3G. So for that sense, it makes more sense to reform 2G spectrum first. And I mentioned US. They have spent a lot of efforts into rolling out 4G, 5G networks the last couple of years. So they feel that they are ready to shut off both 2G and 3G. While Africa, as you mentioned also, still a high dependency on feature phones. They have some financial services and other things that are based on 2G. Probably it's going to stick around for quite some time. So I think this is the complexity of it. It's not easy to say that this is what's happening globally right now. It looks quite different actually from market to market or even geographies. So, but that is something that players like us, of course, need to do our best to keep an eye on and understand the market dynamics of it from a global perspective, since our customers often have a global perspective on their deployments.
And you mentioned a concept there, which is refarming spectrum. So as 2G or 3G are shut down, is some of that spectrum being used for 5G, or where would the use be for that spectrum as it's freed up?
Yeah, you're right. Spectrum could be seen as a natural resource which is not endless. You have, of course, if you scale up in frequency, you have quite a lot of spectrum still to be used, and I think that's where 5G sometimes come in. 5G is built in a way that it can utilize the high frequency spectrum. We talk about the millimeter wave band and gigahertz, well above the traditional 2G, 3G spectrum that was used. But also, I think I mentioned that the spectrum that has historically been used for 2G and 3G technology, primarily in the lower spectrum or lower frequency bands, is quite precious for us operators and of course then also for the mobile subscribers, because the low frequencies has typically a better propagation, so it covers areas and geographies in a better way. And for IT, I think that is particularly important, since a lot of the IT devices might be installed in basements and even on the roads and stuff like that, where you have sensors that should control the pumps or electricity meters or what it be. So I think the use of the low frequency bands and making that optimized for future IT deployments is quite important. So that is one of the reasons why you want to reform the spectrum, because the modern technologies can support much higher rate or higher connected devices per cell site than 2G and 3G can.
Very interesting. Well, let's move into then the practical implications of this for, I guess, at least two audiences. Maybe there's more, but one would be IoT device manufacturers, and the other would be the device owners and operators. So how do you look at this? Maybe first, how do you look at the companies that will be impacted, and then what would be the impacts for them?
Yeah. I think one of the worst type of impacts that could happen, and I should be clear on that, is that if you're a device company that has connected devices in the field right now, and you happen to have only legacy technologies in that device, and you happen to be in a market where all the networks are being shut off, for the legacy, then you could be stranded. You could be there, lose connectivity at the same day as the network is being shut off. And that is, of course, the worst case scenario. And you should do whatever you can to avoid that, of course. But I think in a more positive note, I think the impact is that you should now most likely start to prepare for this transition into the new technologies, unless you already have modems and devices that support also 4G, for instance.
Yeah, got it. So what does that look like? I guess if you have, let's say you have different situations, you have devices that are already in the field. And I guess if the device is very, kind of a small IoT device, a small sensor, low cost, maybe you just brick it and put a new device in the field. If it's maybe a more expensive asset, then I guess you send somebody out there to change the modem. So you have this management of devices in the field, and then you have products that are still in production that they might have devices already sold, but they're still in production. And so then you might be looking at redesign of those products, I suppose. And then you have obviously future products that are in planning and planning for the future, which we can handle separately. But what's the roadmap for a company to think through? How do I manage my devices that are either already in the field or that I'm manufacturing today?
Yeah, I think, of course, information collection is the first phase here to assess the situation, see what markets am I exposed to, where do I have installed devices, and what do they support. And that's a bit of an information gathering. I think it can be done in many different ways. Obviously, whenever we have customers, we try to help them with this, get a lot of questions, of course, and we also push out information whenever we know that there's going to be a sunset. I know the GSMA, which is the association for most mobile operators are connected to, they try to keep a published list of all publicly announced sunsets that will take place. I say publicly announced because it's not always that all operators are super transparent, unfortunately, with the plans. And that is, of course, something that we encourage everyone to be, because it will impact the IoT customers eventually, unless they know well in advance what's going to happen. But I think GSMA published a list. There are press releases or another public communication, of course, from some operators. We have, since a number of years back, had as a routine to regularly, from our perspective, ask our roaming partners if they have any plans. And sometimes we get the information well in advance, but it's, of course, always up to the operator itself to decide if they want to share this. But once you have that information, once you know where you have your devices and what plans are in place for that region, I think that's when you need to do the cross-check and see what kind of lifespan do I expect from these devices. Are they expected, if they only have the legacy network technologies to start with? That's of course the first check. But provided they have only legacy technology in place, how long do I expect them to be still operational? And is that timeline longer than what I expect the network operators to maintain the networks? Well, then I have an issue, of course. And then you need to start to prepare. How do I address this? Is it replacing the device entirely, replacing the modem? You're absolutely right. I don't think that all IT devices have a cost that motivates replacing a modem. That might be even more expensive. But then, of course, if you have an expensive device, a big machine or of some sort, or a car maybe even, then it might be very well relevant to replace it. But maybe you can run it in an efficient way. Maybe you can combine it with a service window that you're already visiting device or something like that to avoid an additional field trip. I think this is extremely dependent on the use case and the actual application and how it's being operated. I know also for a fact that there are a number of sensors that you install once and then you expect it to just sit there, and it doesn't have any maintenance window because it's not meant to have that, and maybe it was not even calculated for in the original business case. And then of course you need to assess what that means for you in a situation like this.
Yeah, and what about for the products that are in production today and that maybe have modems for 2G, 3G, but also maybe have also hardware that supports LTE-M or NB-IoT? What would be the thought process for deciding, do we want to redesign this to maybe take out the 2G, 3D hardware so we can reduce BOM cost? Or I guess it's a similar calculation of how many of our customers are going to value this. But how would you advise companies that are looking at this design decision and determining, okay, when do we redesign our products?
It's a very important question, and I'm afraid it's not one answer to it. It's one of those "it depends" type of questions, unfortunately, and something that we also spend quite a lot of time on and coaching our customers on doing the right decisions along the line, because it has a dependency once again to the geography, which I mentioned. It looks very different depending on where in the world you are, and some are only deploying their IT or planning to deploy their IT devices in a certain region. And that could mean either that you have to maintain the legacy technologies a little bit longer than originally expected, because you know that you're exposed to markets where you will be dependent still on 2G, 3G for coverage reasons maybe. Or it could mean that you can be more forward-leaning and start to deploy devices even without the legacy technologies embedded, because you can save some cost on it, and you're safe and reliant upon 4G and 5G to provide the coverage that is required for the application to work. But it is really a timing issue, and I think that's the tricky part or the tricky situation we're in right now. This midlife crisis that we sometimes talk about in our company, that we cannot say that we are not dependent on the legacy technologies, not even for new deployments. Actually, if you go global, you probably need not only the 4G based LTM or narrowband IT technologies, but you also need 2G technology for having coverage in markets like Africa and certain other geographies. Even Europe, actually. So yeah, that's an unfortunate situation, but it's actually where we are right now. We are in this transition still.
Does that mean in some cases, I guess one product would have different feature sets that would operate differently in different geographies based on the network connectivity? So you would have then maybe certain feature sets that wouldn't work in a geography with 2G, but would work in one which is served by LTE. And I don't know, hypothetically, the reverse, well, you might have different cost structures also related to data consumption in the market with LTE-M. You might have to build that into the business model of operating the device versus 2G. I mean, are there implications here for feature availability from the same device in different markets, and also the cost structure? I think a lot of device manufacturers are moving towards service-based, where they're not necessarily selling the CapEx, but they're selling a device with certain functionality for a monthly or an annual fee. Do you see kind of implications for these business models?
There could be, but not necessarily. Actually, it's I think on the features side, which you mentioned, there could be different capabilities. Specifically, if you look at the newer technologies, you mentioned LTM and narrowband IT, which come with additional features that we haven't had in the mobile industry before. Actually, these are the first technologies that are built and specified for the sole use of IoT. Historically, we have used 2G and 3G networks, but those networks are actually built for other purposes, the handset business primarily, or mobile broadband business. But we managed to squeeze in M2M and IT applications on top of those networks anyway. But LTM and narrowband IT are different, and this means that they have functionality like very power efficient sleep modes and things for extended coverage, and so that would be quite relevant for a lot of IT applications. And obviously you will only be able to take advantage of that when you're connected to one of those networks. If you have a modem that supports both the new technologies but also 2G, and you are in a 2G network, obviously you're not capable of benefiting from these new functionalities. So that's a given. So here you might have different experiences depending on where in the world you are. And I know that we have some customers, for instance, that have built smartwatches and other peripherals and have made the decision to go with only LTM, for instance, because they see that that's the future. They know that they don't have coverage everywhere in the world right now, but it will come eventually. And but leaving out 2G has such a good power consumption benefits, so that they've chosen to go all in on LTM already now. So that's that could be the case. Cost-wise and business model-wise, there could be differences, but I'm not sure that it's a common thing actually that has a big impact. Quite often you pay for the data, or you pay for the connectivity, regardless of what kind of technologies that are being used for communication. So hopefully you have a good business case, regardless if it's going to be on 2G or LTM or something else. So that you can do this business transformation and move into more service-based charging, or whatever it is that you want to bundle together with your product. And I think that's something that we see quite often right these days. Customers that want to shift from being a box shifting product company into a service-based company, where they also use the IoT capabilities in the devices to enhance the experience, and maybe be able to sell water instead of pumps or something else. So yeah, I think that trend is quite strong.
Okay, and so if we start thinking about the future here, it sounds like migrating to NB-IoT and LTE-M is going to be the path for most companies. So a couple questions here. Number one would be, are there other technologies that are also kind of suitable as a next generation solution for IoT devices? And then the second would be, what differentiates NB-IoT from LTE-M? I've seen that Europe and the Americas tend to have adopted both of those. Asia, it seems to be a little bit more leaning towards NB-IoT now. But what would be the decision factors for a company selecting one over the other?
Sure. I think Narrowband IoT and LTE-M are to me, from a cellular connectivity perspective at least, the most natural candidates for replacing both 2G and 3G actually. There are obviously other choices, and depending on how you play your cards into a transition phase like this, it could be so that you actually seize the moment. Maybe you have done business based on 2G for a long time, and that has served you well, but now, when you anyways are facing a shift towards one of the newer technologies, you might want to enhance your experience and maybe take this step into becoming a service-based company instead of a product company, or whatever it might be, which in turn opts in for an enhanced experience that takes advantage of even 5G services, edge computing, and what have you, all the fancy things that we are seeing in the networks being deployed right now, and might be the reality, at least from a global perspective, might take a few years. But on a local perspective, you might start to benefit from 5G services already now. So, I mean, then you might go that route. But if you're looking for more of a drop replace type of scenario, then I guess that LTE-M to me is maybe even the primary candidate actually above Narrowband IoT. And that leads to the second part of your question: what's the difference between those two? I think one of the differences is that Narrowband IoT, in its specification, could even be seen as even more lean actually than, for instance, 2G. Yeah, you can't expect to have higher data rates, rather the opposite, and you might even experience a drop in things like latency, because you could have up to 10 seconds of latency, a round trip time for a Narrowband IoT network. That's not unusual. So Narrowband IoT is quite limited in that sense, but it's also limited in terms of cost for embedding it as technology. It's limited in power consumption, so it performs, of course, way better than any 2G modem has ever been close to, and so on. And it has good capabilities of reaching deep indoor coverage and such things. So you have advantages, but to some extent it's more limited than even 2G. While LTE-M, I'd say, beats 2G on all aspects. It's faster. You have up to megabit of a second data rates already now. You have a latency that is on par with any 4G network, like 10 millisecond or something like that. So you can do real near real-time applications from it. And power consumption is better in all these things. So it really only make things more capable, actually moving from 2G to 3G to LTE-M, and I think that's a good thing in this transition, that you have LTE-M available. Also, from a mobility perspective, network handover and stuff like that, if you have moving devices, it's much better supported in LTE-M than narrowband IT. But it's up to your application to see what do you need to optimize for. Is it the most power efficient and cheap implementation that is required? Then maybe narrowband IT is the choice for you. But if you have a little bit more demanding applications, maybe you see a need for future firmware upgrade campaigns or something like that require a little bit more bandwidth, then I think LTE-M is most likely the primary choice. And I foresee that, at least for these international deployments that spans across different networks and so on, I think now LTE-M will actually be the first choice for many because of the fact that it has a little bit better capabilities and a lot of things work more smooth there. But if you have maybe a mass deployed water metering case that requires some extreme performance in certain aspects, then narrowband IT must be the best choice for you. So it's not a either or; they complement each other quite well, actually.
And in terms of geographic coverage, would you expect to have more or less universal geographic coverage for both of these networks within the near future, or do you also have to look at availability in different regions?
No, I actually expect to have them both available everywhere eventually. Then right now in this transition phase and rollout phase of the networks, you might see geographical differences to some extent, and you still do. But I think that's more of for tactical reasons. Basically, maybe you have legacy 4G networks that have been capable of being upgraded to one of them, but not the other. But as you roll out 5G and such things, I think then most operators will have access to both technologies, and I don't see a reason for not launching both of them. Actually, I think there will be plenty of use cases and devices that require both.
Okay. Yeah, for myself at least, and maybe for some of our listeners, there's always a bit of confusion between LTE-M and NB-IoT and then 4G, 5G. So could either of these networks be built on a 4G or 5G network? Often NB-IoT seems to be a bit more connected to 5G, but so is both possible? And then is there a difference between, let's say, NB-IoT on a 4G network versus a 5G network?
You're excused. This is not an easy thing to understand unless you take the time to dig into it into more detail, and it is confusing. Let me put it this way. Both LTE-M and narrowband IT are, as I would say, 5G technologies because they have been specified together with the 5G standardization work. So in that essence, they are part of the 5G standardization. Then, that said, due to time to market aspects, because we all saw IT taking off in a quite rapid pace, actually, and putting demands on operators to have networks capable of supporting this ever-growing connected devices, then LTE-M and narrowband IT have been implemented in a way that they could be built on top of legacy 4G grids, meaning that the hardware we've been using for 4G could, in many cases, not all cases, but in many cases, be upgraded to also support LTE-M and or narrowband IT. And here you could see some differences depending on how old 4G infrastructure did you have, what kind of vendor did you have for your 4G infrastructure, and so on. Some supported upgrades to LTE-M well, others supported upgrades to narrowband IT well, and some did both, and others did none. So there are some differences here, and that's why we might see differences in rollouts globally as well, or from operator to operator. But over time, these things will blend together, and the 5G networks that are being rolled out, they will support both LTE-M and narrowband IT for sure, and it's also part of the roadmap and the long-term life of 5G. Even if 5G in itself also introduce a new radio that is only capable in 5G infrastructure, not 4G backwards compatible. But LTE-M Narrowband IoT is sort of a bridge between 4G and 5G for IoT, launched as early as possible because we, as an industry, have seen the need for it, but definitely will stay around for the longevity of 5G. I don't know if that clarified things or made it even more confusing.
No, that helps a lot. That helps a lot. Thank you. Yeah, I've always associated NB-IoT with 5G, but then it seems to be used for 4G. So you've now made this much clearer for me. In general, I now feel much better informed about the network situation. I think we've covered a good bit of territory here, Martin. Is there anything that we didn't touch on that's important for folks to know?
No, I maybe just a final word and wrapping it up. I think I fully respect the challenge that some enterprises are facing now with this transition and sunsetting of the networks. And of course, we will do as a representative of the industry wherever we can to support in that and help plan for doing the right choices in the right time and so on. But I think also take the opportunity now to look forward. Not having your IT devices and use cases too much linked on technologies that actually have been around for decades in this fast-paced industry, but rather take advantage of what comes around the corner, plan for some feature development upgrades in your devices, those service launches that you've been hoping to do for a long time. Maybe now is the right time to do it, and so on, to try to turn this into something positive as well. At least that's what I'm trying to do myself. And for sure, the future is still bright, and we have great networks coming up now that will really help to speed up this IoT transformation even further. So that looks promising, I think.
Yeah, wonderful. Well, then just last question from my side. I know you've launched some white papers recently that also help to clarify the situation. If some of our listeners are really trying to navigate this situation now and looking for support with that, what's the best way for them to reach out to the Telenor IoT team?
I think the best way is probably to go to our website and go into Telenor IoT website, and there we have our resource library available. Of course, you're more than happy to reach out to your closest representative as well. Maybe we can support you even better if we have a dialogue about it.
All right, wonderful. Well, Martin, thank you for your time today.
Thank you. Thanks for inviting me.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@IoT1.com.